Hello, thanks for having me. We are going to spend 45 minutes talking about trust, what is trusted software, and what are the foundations of security in regarding to the software. Short information about me, and maybe because I've got some code on the slides, and there are still some free seats in the front row, so maybe you want to get a little bit closer. I won't bite you, I promise. Okay. So I am a pen tester, open source committer, and from time to time I found some security issues. You probably know the PHP project. I'm not going to ask you if you use NetBSD because your answer will probably amuse me. So what is this all about? I've got some background also as a software developer. I was working for several years as a C coder or Python coder or even Haskell coder. And I was always wondering if the code which I wrote some particular day really works. And you know, it drives me a bit insane. So that's probably I work now in security industry. And goal of this talk is to see how many assumptions are hidden in belief that some code is secure. And I want also to share with you some of my findings. You will see some previously unreleased bugs in OpenSSL, for example. So it's gonna be fun. So yeah. So what is trust? It's always good to define what we are talking about. I was digging in dictionaries, but that was pretty useless work, in fact, because you know, dictionaries are not referring in any way to software, and moreover, if you will try to find what is trust, you will find links to another word, which links to another word, which links to another word, and then you get to trust again. So if you will compute the fixed point, you will get pretty useless definition. So instead of you know, weak dictionary definitions, I decided to put the image on the slide because some people believe that it's worth more than 1,000 words, and I agree. And what do you think? We are the hands that feeds or the bird in regarding to the software security? Okay, I can tell you that in fact we are the bird, but and you know, if I pull the rabbit out of the hat, I can finish the talk here, but I promised you some bugs in OpenSSL, so show must go on. And if I say that some that some software is trusted for me, I really mean that it satisfies two properties. First one is that it doesn't hurt me. For example, I expect that my PDF viewer is not will not delete all my files upon I open the document in that program. And the second one, that software does what I think it does. So I would be surprised if my favorite PDF viewer sends data to some kind of cloud or something like this. And what is trusted software? It actually relies heavily on the requirements and many other variables. So you can have, probably each of you have your own definition. But since we are on the security conference, I guess that we can assume that all of us are a bit paranoid, and this is probably the most interesting slide of this presentation because I expect some discussion. And my question is, do you use, for example, Linux software? Never. Me too, only NetBSD or BSD software. So who use Linux software, raise your hand. Do you trust it? Okay, no reaction. I trust it, but not as much as, for example, OpenBSD. So what about Windows? So if you are not using Linux, then probably all of you use Windows software. Is that true? Yes, some of you use Windows software. Do you trust it?
Definitely.
Okay. I see also comme ci, comme ça reactions. So, well, regarding the OpenBSD, I must admit that this is not first one when I present those slides. I gave a talk 2 years ago at Security Besides and collected some let's say, comments from that talk, and people were very confident that OpenBSD is secure software because they implement so many security mechanisms. Do you agree?
No.
No, okay. Okay, and what about the cloud software? Do you use, for example, Gmail, Dropbox? I'm sure you're using it. And this talk is not about software, cloud software, whatever it is. This is actually a very true picture. It's not funny, I guess, for all of you that keeps data in the cloud. And remember that there is no cloud. There is just other people's computers. So let's focus on the real software. And from my interviews with many people, I have following observations. So people rather trust small software. For example, Excel is not a good example because if you want to add, for example, 2 numbers, it would be probably better to use something smaller. And what is funny, people trust, maybe not funny because this is based on our intuition, people rather trust open source. And Linus, who created Linux project, stated his own law, which is as follows. Given enough tables, all bugs are shallow. How many of you ever read any open source code? So yeah, I would say that it's less than 50% of people in this room. So we rely that some group of programmers, developers, security professionals or whatever read the code and it is secure. And of course, in regarding to open source, we can verify code ourselves, but you know it's not possible when you get, for example, from FreeBSD like 15 million lines of code. You can even scroll that code in a some sane time. And I'm pretty sure that if you really use any kind of Unix or Linux, you use binary packages. Have you ever verified them? For example, if they were compiled from the code which is available in the internet? Probably no. And well, now it is possible because some projects like Debian or FreeBSD are working on the builds that can be reproduced in your kitchen. So you can verify yourself that the binary set is actually compiled from the source code, which is publicly available. And of course, we rather trust software with a good reputation. Well, probably that run no longer is well, I would today put here another system, not Windows, because now it has many security features, and I think it's pretty secure right now. But I don't want to talk about, some generic ideas. I want to take particular software, expose it to the internet, and see what would happen. So I want, for example, to factor that software into prime factors and see if they are secure. So what do you think? Which software we can choose in order to do such experiment? You can pick any software. I created like 20,000 versions of this talk. OpenSSH. What a great choice. So by acclamation, we are choosing OpenSSH. Why? Because it's relatively small. It has good design. It's well written. Also, well, I usually enjoy reading code, but OpenSSH is pretty good code to read. If you, for example, want to see how to implement security mechanisms, take a look at the OpenSSH. And well, that's not only my opinion, but also Kinko. You probably know him. He thinks the same. And it's actually very popular software. I'm sure that all of you ever used OpenSSH, directly or indirectly. Actually, ZMAP made some scans a few years ago, and the hit rate was pretty good. And who has seen the Matrix movie? Can you recognize this scene? Yes, so to be honest, I haven't seen that movie, but friends told me that there was a girl, his name was Trinity, and she was breaking into some plant or something like this. And actually, she used a bug in OpenSSH. So can we trust OpenSSH? Well, it was more than a decade ago, so let's see how things looks like today. And by the way, I guess that this bug was found by a very known American researcher. So trust boundaries, here we go. Here are the trust boundaries, and here is some graph that I factored the computing environment into prime elements. And here we have some boundaries between the elements. So in the modern world, we have binary, which is linked in dynamic or static way to some libraries. Then we have kernel, CPU, other hardware, physics, and who knows what is behind that. So Captain Obvious to the rescue, some pretty simple observations. If we are running, for example, our software on untrusted hardware, then software is no longer trusted. And even simple software has rather complex foundations. For example, if you will put here Hello World program, you will see pretty similar graph. Because, for example, Hello World needs a kernel, and that kernel is usually more than few million lines of code, you've got some drivers for display, etc., etc. So even simplest software is not simple anymore. And our goal for now is to see if each node of this graph is secure. So this is left here for some historical reasons. Few years ago, I was auditing the code which is responsible for key authentication in OpenSSH, and developers added some functions to handle certificates, and they made some silly mistake because you know, SSH is a pretty defined protocol. There are some documents, RFCs, or something like that, that states how SSH should look like. And there are also documents which specify how certificates should look like. And here is the code that parses those certificates. It doesn't matter what is it exactly, but OpenSSH let you to produce key, which certificate, which is signed by certificate, which is signed by certificate, which is signed by certificate, so some kind of matryoshka, and you will get those two functions calling themselves recursively, and they've got pretty big stack frames. So as a result, you can get stack overflow, but fortunately, those certificates are kept in something which is called chunks, buffer chunks, and they're limited. But so no cookies this time, but probably there exists some, you know, exotic architecture where stack is pretty bounded and something important is near to it. So for now, it's not exploitable. It was fixed many years ago in OpenSSH, but it shows that not necessarily OpenSSH is bug-free. And another example is actually the real bug in OpenSSH. This is pretty fun bug because OpenSSH developers made some mistake with those certificates. They used a field called nonce, and some, you know, very smart people who know cryptography told them that that nonce field should be replaced. As far as I remember, they suggested to put this field at the very beginning of the certificate, and they implemented it, but made stupid mistake that when you were issuing the old type of certificate, the nonce was not initialized, and the problem here is that you will get in public certificate a part of your stack memory, which in fact can, for example, contain some data from your private keys, for example. So it was fixed also many years ago, but now it's still possible, for example, to perform timing attacks against OpenSSH. There are several tools in the internet to do so. So I guess that OpenSSH is for now secure, but we can see that something can happen and it might be unsecure. So what about the libraries? Because OpenSSH does not implement whole libc and stuff, so let's see. By the way, we have only 4 libraries on this slide, because those 4 libraries are used directly, in indirect way by OpenSSH, but actually if you see on Debian, for example, there are nearly like 15 libraries used indirectly by OpenSSH. So if you run OpenSSH on non-OpenBSD platform, you will need libopenSSH compat layer, which implements the functions which are not part of libc that your system uses, because OpenBSD developers added several functions that help them write code in secure way. So they decided to write some kind of glue which implements those functions for other platforms. And this part of code heavily relies on OpenSSL. So let's see if OpenSSL is broken. If OpenSSL is broken, then this library will be broken too. So OpenSSL. I guess that all of you ever heard about OpenSSL. Some people have pretty bad opinion about this code. Actually, many developers from BSD world thinks that this code is pretty bad, but actually they use it, and all of us are using it, and it's pretty fun that we think both that this is unsecure and we are using it. Many projects rely on OpenSSL. I have investigated FreeBSD ports, and it looks that indirect way more than 700 ports use it. And you know, C coders are, you know, coding in C is in general very hard thing, and you can't write in a good C code and know everything about cryptography. And there are some rumors that actually people behind the OpenSSL learned C by writing this library. Well, it might be true if we will see what is inside the code. Then there are many funny comments in the code. For example, I don't know why it is initialized that way, or don't think this is used. Just disabled all digits for now because it sucks. So you know, it's pretty bad that our security relies on this library. If you want more golden quotes for OpenSSL, then subscribe OpenSSL Fact at Twitter. So after famous Heartbleed bug, OpenBSD guys decided to fork the library and to remove from the OpenSSL all things that are not used, for example, in the OpenBSD. And so in general, people think that this library is more secure than OpenSSL. So let's take library SSL and see if it's secure. That's funny thing that favicon of icon of library SSL is actually Heartbleed logo. So you know, that code is quite big. So I decided to take a look at the small sub-library which implements big numbers, which should be pretty easy. And don't get me wrong, I don't want to blame OpenSSL developers for anything, because I think that, you know, it's fault all of us that we let our security into their hands. So okay. Anyway, it should be a really easily to implement that code without bugs. But actually, library SSL use 3 representations of 0. 0 minus 0 and 0, 0, 0, 0, 0. The last one is actually not legal, but if you are using library SSL without debug routines, it's perfectly legal in the code. And the problem is that sometimes those zeros equal, sometimes not. So let's see if inconsistency can't hurt us. So here is the first off by one in library SSL. We can get somehow minus 0 and apply it to the function which translates the big number into the hex representation of number. And if we will take a look at this code, for minus 0, it will allocate 2 bytes here as a top is 0. But in fact, we write to the string p 3 bytes. One byte is written here, one here, and one here. So we will get classical off by one bug, which probably can't hurt us, that much as heartbeat, but obviously it shows that something is wrong with this library. And there is another example. If you can pass your own value to bnrand function, which gives you random bits from the system or from the library, it doesn't matter. So if you can control this this argument, you can put here a 1. So let's take a look. If you put 1 into the bits, then you will get here bytes equals 1. So we would allocate 1 byte of memory, but here we are writing actually 2 bytes, or affecting 2 bytes. So another off by 1 example. So I guess that those 2 bugs show that library SSL is not necessarily secure. Regarding to libc, I want to skip that part since this bug is pretty complicated, and to be honest, I pasted here updated code, so there is no bug actually, but at the zlib page you'll find frequently asked questions, and the developer thinks that this bug is actually an optimization, but they fixed that. So regarding to libc, there is a fun story behind that, because we found a bug during last year's DEF CON qualifications. We downloaded the binary and ran it on our test server. And actually it was kind of shell, and we were running several commands with Polish bad words, which some of them contain some characters which are handled by libidn, and we triggered double free in the get address info, and we thought that it is a part of the task, but actually it wasn't. But the bug in the glibc was real. So let's see if kernel is secure. So if you take a look at the kernel, there are millions lines of code that running next to each other on same privilege level. There are everything, network protocols, file systems, and many more. And this is example of the bug in the FreeBSD code. It actually fixes, so it's not pretty important to analyze that now. But let's see the NetBSD example. This value is 100% taken from the user length, so user can allocate as many bytes as he wants. And in fact, he can take all the memory in the system and make the system panic. And this bug is not exploitable in on x86 architecture and AMD 64, but in fact it's exploitable on Spark 64. After the presentation, I can tell you why. And this is another example. This is a bug in the library which is used to exchange the data between the user land and the kernel in some structured way. You use the plist or something like that by Apple standards, and here is the loop that can hit the unmapped page and make the kernel panic. So let's go a bit deeper. There are obviously bugs in the CPUs. There was a talk many years ago at Hack in the Box done by Chris Kaspersky, but actually not many details were there. But obviously, if you remember the Pentium processors, you probably remember bugs in those processors. Also, if you, for example, take documentation of evaluation boards of, for example, TI products, you will find that there are in fact many bugs in hardware. And I guess that none of you ever wondered what's inside the firmware. And have you ever, for example, worried if your CPUs are backdoored by, for example, NSA? Remember or recall the rumors around the RDRAND opcode, which was forbidden in the FreeBSD. So for the moment, we will talk about philosophy. You know, if you will think how physics work and if it's consistent in whole universe. For example, if you will pass the question to your favorite search engine, you will find many runs about it. We don't know how physics works. You know, millions light years from here, but we expect that it's constant. And probably OpenSSH will not suffer because of that. But if you want to send your code outside the solar system, then probably it's not funny anymore. So we don't know still what is behind the physics, but there is one quote actually by testers which I really like, and it is that in God we trust, everything else we test. And there are some fallen actors. Actually, we haven't talked about the protocols. Obviously, there are bugs in them too. We can formally prove that there are no bugs in SSL. For example, modulo some models, so it's not 100% bug-free. And remember that the absence of proof is not the proof of absence. Also, in regard to algorithms, we can use math tools in order to verify algorithm, but actually there is a long road from the verified algorithm to verified code, because we have to pick up some language with formal semantics, code it, test it, verified it, and then we should recall that we need a compiler that is verified. And since OpenSSH is written in C, we need a verified compiler in order to fed our machine. And obviously, there are many bugs in compilers. There was a fun research done by some American scientists, and they found more than 300 bugs in popular compilers. There is a project called Concert, which goal is to make a verified compiler, and it means that the code that we get from this compiler is 100% consistent with the semantics of C standard 90, but actually there was a bug in that code, and if you take a look at the translation process, it's insanely complex. So I'm pretty sure that there are more bugs. So what are the conclusions? So of course, it's always better to be paranoid than sorry. Read the code or not be surprised. It's actually good for us pen testers that will never get rid of bugs in software. But to be honest, all those liars works usually fine. You know, I run some instance of OpenSSH, Apache, and other servers, and usually I sleep well. So I would like to also say thanks to Marek Roemeka and Filip Palian, who helped me a lot with this presentation. Some bugs presented here were found in cooperation with them, so thanks to them. If you would be interested in some other concepts of what is trust, then you can take a look at those links after the conference. And this is time for questions.
Please wait.
So when you mentioned OpenBSD before, and then at the end of your slide deck, you showed the statement from OpenSSH, better paranoid than sorry. What's your opinion about OpenBSD? I mean, they are actually trying to be very paranoid and implement all these, things that will make exploitation very difficult, even if you find a bug. So what's your opinion on that?
Well, I think that it's hard to compare OpenBSD to any other project because they are kind of group that is pretty closed, actually. If you would like to talk to them about security, they probably would tell you that you are completely idiot because security should work like this or some other way. And my opinion about OpenBSD is that they have many security features in user space, but actually there lack mechanisms to protect kernel space. I guess that, for example, they still don't have ASLR in kernel, for example. So, it's hard to say. I personally trust OpenBSD, but I think that GR security with Linux is probably more secure. But it's hard to measure. It's just my intuition.
Thank you very much.
Thank you.